3.7 Derivatives of Logarithmic Functions. So let's take a quick look at this comic right here, which is really cute. And you're not going to really understand this comic until we get to the second half of the course, where we start undoing the derivative or take the integral. And I'm going to have you take a look back at this comic because there might be a little mistake in it. So we're going to talk about that later. Before we get started with taking the derivative of log base a of x, let's do a quick little review of what y equals log base a of x means. Y equals log base a of x is equivalent to a to the y equals x. So these two statements are synonymous. What we want to try and do now is actually find what the derivative of log base a of x is. We are going to start with our a to the y equals x. And then we're going to just take the derivative of each side. And recall that we had learned that the derivative with respect to x of a to the x equals a to the x ln a. So that's an important one that we needed to remember. The derivative of a to the y is going to be a to the y ln a times, and don't forget to chain, that's our baby, so times y prime equals, and the derivative of x is just 1. So if we want to solve for y prime here, we have y prime equals 1 over a to the y ln a. And remember that we originally said that a to the y equals x. So if we make that substitution and we let a to the y equal x, then we get 1 over x ln a. So what we just found is that the derivative with respect to x of log base a of x is 1 over x ln a. So this is one that you will be seeing on the AP Calculus exam. So as we just said, we learned that the derivative with respect to x of log base a of x is 1 over x ln a. Now let's take a quick look at a special case where we let a equal e, meaning that we have log base e of x. And we know that log base e of x is just the natural logarithm, or ln. Log base e of x we can replace with ln x equals 1 over x ln e. And we know that ln e is just 1. So we have 1 over x. And so this right here is a really important one that we're going to be using a lot this year. Before we move on, let's quickly take a step back and derive this in a different way. So we just said that the derivative with respect to x of ln x is 1 over x. Knowing this, let's go ahead and look back at our original problem, which was y equals log base a of x. And if we use our change of base formula, we can say that equals ln x over ln a. And I'm just going to separate that out into 1 over ln a times ln x. Those two statements are equivalent, right? And the reason I'm doing that is because in the next step, I'm going to want to take the derivative of both sides, and 1 over ln a is a constant, so I'll just be able to pull that out and it will make my problem much nicer. So like I said, let's take the derivative of both sides. So the derivative of y is y prime, and then the derivative of this, well, I can take the constant out, so 1 over ln a times, and then the derivative of ln x is just 1 over x. 1 over x. So I get 1 over x ln a, which is the same thing that I had proven before. Okay, so now we can move forward and let's do our first example. So differentiate y equals ln of x cubed plus 1. So clearly this is our baby and we're going to need to chain this right here. So y prime equals the derivative of ln box is 1 over box, and so that's just our x cubed plus 1, and then we need to chain it, so the derivative of x cubed plus 1 is just 3x squared plus 0. So we get 3x squared over x cubed plus 1. Not too bad, right? Now let's go ahead and take the derivative of ln sine x. So clearly we need to chain again, and that's going to be our baby here. We have the derivative of ln box is just 1 over our box there, times the derivative of sine x is just cosine. So we're left with cosine over sine, or cotangent. Okay. Now we want to find the derivative of ln root x, and I'm going to just rewrite that as ln of x to the 1/2 power. And so clearly this is another chain rule, so that is my box. So f prime of x is 1 over x to the 1/2 times the derivative of x to the 1/2 is 1/2 x to the negative 1/2. Let's go ahead and just simplify this down a little bit. So I have that 1 over x to the 1/2 times 1 over, and this goes down, so 2x to the 1/2. In other words, 1 over 2x. So that's my answer there. If f of x equals log base 10 of, here's my baby, then I have the derivative. Let's quickly remind ourselves that the derivative with respect to x of log base a of x was 1 over x ln a. Okay, just a reminder there. So we have 1 over, and instead of x here, we have our whole 2 plus sine x, 1 over x ln, our a is 10 in this case, that's our base, right? Times, don't forget to chain it, the derivative of 2 is just 0, and the derivative of sine x is cosine x. So that is our answer, cosine x over 2 plus sine x ln 10. Finally, and this is an important one that we are going to be investigating even further later when we get to the second half of the course, where we're undoing all this stuff and doing our antiderivatives, so we're going to keep this one in mind also. If f of x equals ln absolute value of x, then how do we find f prime? So to start this, let's just rewrite our original function as a piecewise function, that ln absolute value of x. Well, we know that ln absolute value of x, if x is greater than 0, then we just have that the absolute value of x is x, right? But if x is less than 0, then the absolute value of x is the opposite of x. In other words, ln negative x. And of course, you cannot take the ln as 0. ln 0 does not exist, so this is strictly greater than and this is strictly less than. Now that we've split it into a piecewise function, it's much easier to go ahead and just take this derivative here. So let's do this for if x is greater than 0 first. So the derivative of ln x we know is just 1 over x. Nice and easy. What about if x is less than 0? Well, the ln of negative x, don't forget this is a chain rule and this is our baby right there. So the derivative of ln negative x is 1 over negative x times, what's the derivative of negative x? That's negative 1. So that also equals 1 over x. Really cool. So what we just found was that f prime of x equals 1 over x for all x does not equal 0, right? The only thing that was excluded was 0. So that's really cool. Again, we're going to be investigating that more in the second half of the course. And so we want to know that the derivative with respect to x of ln absolute value of x is also 1 over x. And that's it for this lesson. Thanks for watching.